Hey guys, let's take a look at this review sheet. This is going to be the first half, so probably like the first 5 questions, and then I'll do the second 5 questions on the next one. So for the questions 1 to 3, we want to draw a sketch of this function, and then draw a sketch of the first derivative. So whenever we're drawing sketches of polynomials, the two most important things are the x-intercepts, or the zeros, and the general shape of that function. So let me draw a coordinate plane. If x plus 2 is a factor, then I know that one of the x-intercepts is going to be -2. So the function has a 0 at -2. If x minus 4 is one of the factors, it's going to have an x-intercept, or the function's going to have a 0 at +4. So now this is a second-degree polynomial, or a quadratic, because I have two linear factors. It's a positive quadratic, so I know that general shape is up. So I'm not asking you to find the vertex, but just the general shape of it, and the general shape of this is up. And I think I missed both of those zeros, but that's okay. So this is f of x. If we now want to draw a sketch of the first derivative, then I'm thinking about the slopes. So if I were to think about the slopes as we move along this function, well, the important points of the first derivative, or one of the critical points, is going to be, when is that tangent line to the function going to be horizontal? So at this point, the derivative at this point is going to be 0. So looking at this, we have negative slopes as we move towards that x value. They're becoming less negative as we go along, and then 0, and all of these slopes are becoming increasingly more positive. So negative becoming 0, and then increasingly more positive. We don't know exactly how steep this is just quite yet, but the general shape is negative becoming 0, 0, and then increasingly more positive. We have another polynomial where I want to think about the x-intercepts and the general shape. X plus 1 is a factor. -1 is an x-intercept. X minus 3 is a factor. So there will be an x-intercept at 3. Now the degree of this polynomial, 1 plus 2. So this is a third-degree polynomial. It's a negative third-degree polynomial. So from our days in pre-calculus, we'll remember that a negative third-degree polynomial, or a negative cubic, will look like this. So this is the general shape of our graph. We should also remember that if we have a root of multiplicity 2, or a factor that are two of those linear factors, then we have a turn at that root. So we have a negative cubic, where this is a root with multiplicity 1, but then we have a turn at the x-axis here. So there's my sketch. So it's a third-degree polynomial with a turn at the x-intercept of 3. So now, drawing my derivative from here. So looking for the places where we'll have horizontal tangents. So we have horizontal tangents at these two x values. It could be 0, probably. Yeah, we'll call it like right there. And then definitely right here. So looking at the slopes of these, the slopes of this function is negative everywhere to the left of this turning point, and then it is positive from the turning point to turning point, and then negative again. So negative, positive, and then negative slopes. Negative slopes becoming less negative, positive, but then they turn around to become starting more positive, and then they become less positive until they become 0, and eventually negative. And again, this was f of x. And we didn't have to, but we should note that, this turning point of the first derivative was when we had the point of inflection in our graph. So that'll come up in a few questions. So when we stop being positive increasing and start being positive decreasing. So positive increasing, but we stop, and then positive decreasing. Another polynomial. So if x is a factor, we have an x-intercept at 0. X minus 5 is a factor, so we have an x-intercept at 5. This is a fourth degree polynomial. 1 plus 3, fourth degree polynomial, and it's negative. So a negative fourth degree polynomial is going to have end behavior that is down. Some stuff's going to happen in the middle, but then the other end behavior is down. So negative fourth degree polynomial, down, down. We also have a triple root. A triple root from pre-calculus was when we had a turn at the x-axis. So our function, not a turn, a twist. So our function is going to look like this, where we have this turn at the x-axis. Now let's find the places where our derivative will be equal to 0, so when our graphs will have horizontal tangents. This was f of x. So let's bring this down. It looks like it's going to be somewhere between 2 and 3, and then this is definitely going to be 5. Thinking of the slopes of these, my slopes are positive but becoming less positive towards 0, 0, negative, and then negative again. Now let's think about this right here. This was negative increasing and changed to negative decreasing, then back to negative increasing. So we have like an inflection point here. So we're probably going to have like positive slopes, negative, but then a turn is going to happen here at the x-axis. So positive slopes, negative for a bit, but then they become less negative, and back down to negative increasing. So again, just a few comments. How did I know that there was a turn here? Well, it was when this was negative increasing, so concave here, and then back to negative increasing, and then negative decreasing. All right, given this, function f of x, I want to draw f prime of x and f double prime. So the slope of this function from negative 2 to 4, well, this function has a constant slope. In fact, we can calculate this slope because we know points on this line where we go from here to here, we went down 2 over 1. So down 2 over 1 is a constant value of negative 2. So we have a constant slope of negative 2, where this is f prime of x. This is f of x. And then the slope of this slope, so the slope of this horizontal line here is just 0. So our second derivative is 0. And it's important to note that a line has no concavity. So a straight line, because it only has a constant rate and then the rate of the rate is not changing, a line is neither concave up nor concave down. It's just a straight line. Five. All right, the first derivative. When are the horizontal tangents going to be 0, or when is the graph going to have horizontal tangents? So we'll say 1 and then somewhere between 2 and 3. Now looking at these slopes, slopes are negative up until this point, then 0, positive, 0, negative. So, negative, but then become 0, positive, turn back and become negative. And again, we weren't asked to do so, but this point here is where I stopped from concave up and started becoming concave down. So that would be this turning point, the reason why we had a turning point. So these 2 points actually should line up on the same x value. So now, to graph the second derivative, when is our derivative going to have a horizontal tangent? Maybe a little bit before 1, maybe you think it's right at 1, but somewhere here. Now the slopes of the derivative start out positive, 0, and then negative. So positive, 0, and then negative. Again, how steep this is, not something we're too worried about right now, just that general shape. Let's make sure that we have all of these guys labeled. And f of x. Alright, I'm going to see if I can get 6 in, and then do 7 in another video. Alright, first derivative. When does the graph have horizontal tangents? Somewhere between -2 and -3, definitely at 1, and somewhere between 4 and 5. So now the slopes were positive, 0, negative, 0, positive, 0, and then negative again. So positive, negative, positive, negative. Positive, negative, positive, turn back to negative. And then our so f of x, f prime of x, and now we're looking for f double prime. Horizontal tangent here of the derivative, horizontal tangent here. So a little bit there, and then probably somewhere here between 3 and 4. The slopes of the derivative, negative, 0, positive, 0, negative. So started off negative, then became positive, turned back around, and became negative again. So this was f double prime of x. And if we look at these, this inflection point here should match up with this and this. And then same thing here. All of those should share. All of those guys should share an x value. Alright, so I'm going to end this one and start another one for 7.